Perfect.
Awesome.
Okay.
All right. So introducing Dhanush Laxman. Dhanush is a systems engineer with Aurecon who has experience in applying the principles of SE to the domain of rail and intelligent transport systems. He's got more than 13 years of experience working on transportation projects, namely City Rail Link, design and build of urban and interurban traffic management and control systems in Abu Dhabi and elsewhere. Dhanush is also a member of the INCOSE NZ community and has been with us as part of the chapter since the beginning. So Dhanush, over to you.
Thanks, Jess. Thanks for the introduction. Yeah, so I chose this topic just because people keep talking to me and telling me during my days in Abu Dhabi, I always used to face a question, what do you actually do as a traffic signal engineer and stuff? So, and people never thought that it could really be a complicated system. And they just thought that, oh, what is it? You just drive, you wait, you get a green light, you go, you just walk and you press a pedestrian call button, and then you just wait for the green man and just walk and go. And basically what's involved behind, people just overlook that part. And so this is something that I'm passionate about. And so uh, just a little before we go ahead with the topic, I just want to talk about something about me, because I don't know, most of you know me well. So after my master's in 2011, I worked in India for 2 years. I'm basically a traffic and transportation engineer. And and in 2014, I moved to Abu Dhabi and worked for a contractor who was an agents for Siemens. And especially we dealt with traffic signals and CCTV and those kind of systems. And part of my 5 years of my life spent over there. And then in 2019, I moved to Aurecon in Auckland and started continuing the same, but from a consultant's perspective. And then in about the first year, I was in the Auckland Transport Operations Center, seconded there. And then mid 2020, of course, everybody remembers COVID, but then I remember Steve Dennehy. So I met him and I was inspired to choose a career in systems engineering. And that's it. And I think I'm going to be an AC for life for now, to be honest. Yeah. And I'm liking it. And so today's talk would be basically covering what is ITS and what are the systems in ITS and ITS architecture, the V lifecycle model applied to ITS, how SE practices are in ITS, and then the next level down is traffic signals and how adaptive traffic control systems use SE practice, and then the case study of my project back in Abu Dhabi in 2014 and how the processes were applied there and a couple of lessons learned. So to explain what is ITS, if you type in Google, you might get more definitions than this, but I rather choose these two. One's from NZTA, which says that any technology applied to transport and infrastructure to transfer information between the systems and the users. And the next one's like, I really like that one as well, the amalgamation of applications of electronics, communication, analytical, and decision-making tools in an integrated manner. So we'll see more. But in the end, ITS aims to improve safety, efficiency, and environmental emissions on cost per transport. So a couple of examples that you can see for ITS would be common notion is that ITS is only applicable to road sector, but no, it's also there in railways, aviation, and maritime, including navigation and stuff. So it's all there. And basically involves what vehicles, drivers, sensors, and decision tools and communication technologies and their interaction. That's what makes it complex. But then all these parts are hidden within the system, and people don't see that when you drive on the road. So when we see ITS applied to roads, you can see freeway management systems, you can see traffic detections, you can see CCTVs, public transport, urban traffic control, variable message signs and roadworks, and traffic violation recording, lane control, speed control, overhead vehicle detection, events management, and a couple more, parking management and stuff. All these sit under the traffic management system, which can be the high level hierarchy system in that. When we see a regional architecture, this figure is taken from the US Department of Transport. So US Department, the Federal Highway Administration has been really taken pioneered in this adopting SE in ITS. So all the FSWA funded projects have to undergo systems engineering and benefits analysis when they're doing ITS. So they have got a robust process and rigorous requirements and tools that you can use. I'm free to speak about it offline if you want. And in terms of this architecture, consider this is like Auckland City or any city. And the city has goals of developing in terms of ITS, like NZTA, who manage motorways, Auckland Transport, who manage the arterial roads, and council and all the other entities. And they all have a common goal, a common need to, and this architecture would become like an overarching plan where you've got all the user needs, all the stakeholder needs and everything, and then you can just filter it down to the projects that you have, and it forms a long-term planning pathway, in to have it. Not many have done this. I think UK has one and the US has one for now. And when we look at the V life cycle throughout the process, we can see that goes through completely like concept explorations, then ConOps, and then system requirements, and going into detailed design, and then testing, integration, validation, and then operations, and then retirement. Throughout, there would be a lot of cross-cutting activities in terms of interface management and stakeholders involvement and process improvement in ITS, because nothing, I mean, it's all trial and test thing, which I'll explain in the later slides. In terms of where we can see the blue points are basically where you can possibly have a decision guide, hold point, and then stop. Where is this applicable to it? And this approach can be tailored to a project. So if you're just going to replace a single traffic light for an intersection, it's just basically just follow routine processes rather than SC won't provide any bigger benefit in those cases. Whereas if it's complex traffic control systems that you're entirely changing, or you're developing a smart motorway or something, then it can be really taken into consideration. Now, taking a deep dive to traffic signals. So I was introduced to traffic signals mostly when I started working in Abu Dhabi in 2014. And then I realized that my birthday is celebrated as International Traffic Lights Day. So what a career I have. And so just a bit of history, I just wanted to highlight that historically, we all know that, I mean, police officers and traffic officers would have controlled the traffic. And then until traffic signals were actually came into existence. And then it's the process has been the technology has really taken over it. And then from the manual processes to the hand control to an electrical and computerized version of controllers now, from say gas lamps to bulbs to LEDs in terms of the traffic lights, and from having no communications to having copper cables, and now we can have fiber or wireless communication with those controllers. You can actually talk to the controllers through an iPad. And from just operating a fixed time, which is like, say, a time of day signal plans, which would be like, okay, green, 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 same way, equal throughout the day based on the traffic patterns, to basically vehicle actuated, which is like first come, first serve, like which approach has the first vehicle coming, gets the green light first. And in from there, going to the adaptive traffic control systems, which are like basically algorithms based on time, distance, and speed, and a couple of queuing theories and probability and statistics. So yeah, traffic signals have really become smart now. So hence, SE is really required in that space. In terms of adaptive traffic control system, there's many available. Like every now and then you would find each country trying to develop its own. So like US has more than hundreds. So I've just listed a couple of them which are more famous, which is good, which is mostly UK based, but it's extensively used around Europe and US and Middle East and Asia and everywhere. And whereas CATS, it was developed in NSW, so it's more used in Australia, New Zealand, and a couple of other countries. And the next one would be a couple of Motion and Utopia and others, which are like German and European and a couple of things. It's all of these use the same technology as vehicles, which are coming. It's detecting the approaching vehicles and then estimating the queues, which is already there, and then calculating its own timings, and then optimizing it basically, and then that works on for every cycle that it's happening. So just basically using queuing theory. So oops. So my focus would be for today would be the Abu Dhabi's urban traffic control system project. This included replacing 125 intersection controllers, which had legacy controllers there, and replacing them with the state-of-the-art system and having CCTV monitoring and fiber optic communication network. So the whole project included everything from model, build, design, build, operate, maintain for 2 years. So the whole thing. And now comes the point where we can think about what was the problem, but why did they actually approach this? Why was ITS used? So existing controllers were they were pretty legacy controllers having copper communication cables. They run just fixed time of day plans. So it's like, okay, in the morning peak, it's in the traffic signal plans would be prioritizing one direction, evening peak, the other direction, the same way. And there's no detection how much traffic has increased and stuff. And they were facing kind of severe congestion, even though Abu Dhabi's internal road network have minimum 3 lanes on each side of the road. And at the intersections, they do have free lefts. I need to get that. And they drive on the other side of the road. That's the reason. And a couple of things is you couldn't get you have to put in a lot of effort to update those signal plans every year or every couple of years, because with recent land developments, malls and commercial developments, there's a lot of traffic and everything, which has come. And then there was other stuff is limited CCTV coverage. So can this gap be filled by ITS? So yes, it can. So what kind of systems which could help is basically having a traffic management system and a CCTV system. And then the next step would be like, okay, have you articulated all the needs that you have? From this system, that what do you need? What do you need? In terms of the traffic management system to do? what do you need in terms of the controllers to do, and how the monitoring and CCTV system needs to work, and are all the stakeholders in agreement to this approach. That's the consideration which went throughout the process. So, and then the next was estimating alternatives. I mean, analyzing alternatives. So there were a couple of alternatives which were kind of more or less say feasible to do, but then it was like the previous legacy controllers had a copper comms motherboard, so just remove the motherboard and replace it with the new one. That's it. It would be easy, but then the point is that system required a regular support from Siemens Germany and kind of tedious calculations if you wanted to put in adaptive control system. I'll quickly jump to the alternative. Other was like trying to use the Australian New Zealand system, but in support for SCADs in the local region would be we would the nearest vendor was in Qatar, so still there was not expertise within the country, and it wasn't tried and tested within the country, so there was a lot of negativity in that space for this option. And then maybe replace with Sparko controllers. One of the regions in Abu Dhabi had this controllers. So, but then point was if you end up spending the main island and just the other island, but then their whole goal was also to integrate the other islands which had the Siemens controllers. So then the most fit for purpose system that you could have was to adopt the Siemens PC Scoot, where you would have a traffic management system and you could have all the integration with all the other islands and other systems. And you can expand this to include other systems like CCTV, tolling, and ramp metering, and etc. When you have one. And Scoot was already available within the country because the other cities like Dubai and Sharjah already had it. So kind of made that, okay, you've got local expertise to try and train people as well. And that's where I would say that SE was kind of used in terms to identify whether it's technically feasible. Cost wasn't much of a factor there because they were ready to spend money. They wanted to build a state-of-the-art system. So that was really not the point. And then schedule was there. Yes, that was strict. That was like 2 years. You need to implement it, and then 2 years of maintenance. And to manage risk and kind of like going through the process, okay, which one would actually deliver quality into the system and stuff. Then came the subject of ConOps, where we tried to develop high-level functional requirements out of those ConOps, trying to identify the users, their interactions, and just the general ConOps. I don't have to go deep into because probably being SEs, you will be aware. The more other part of in what we do in ITS is try to identify a strategy for each intersection, how you're going to operate it, and a couple of other things was what about whether there is an incident, how you would how would you try to reroute traffic and other stuff, and then that would give you a couple of set of requirements. And then in terms of operations, like are you going to operate? So in Abu Dhabi, we usually operate unlike over here where you operate the through together and then the right together for the approaches. Over there, you don't do that way because you've got really wide lanes and high speed within the city. So trying to agree on a phasing and stuff. So that's the additional thing that we do within that space of ConOps. Going to a next level of detail, and then which would have been helpful but wasn't done for the project. In terms, there was only a project management plan which had a lot of activities, basically SE activities, to be honest. But And then they weren't decision gates. Rather, there were a lot of robust processes of an independent consultant verifying the designs, and then a lot of checks and approvals and stuff. So, and kind of basically agreed with clients during meetings, and requirements were provided. Like they wanted this system to have this facility, this and traffic management system to be able to, for the operator to be able to change very easily, and all those kind of requirements. They were rigorous, but we didn't develop RVTM for that. Pity, it would have been really nice. Would have made my job easier if I knew about systems engineering then. But yeah, then the main activity during this was mainly at the right side of V. Basically, they were more concentrating on how they would do end-to-end testing, validation, and system acceptance testing. That was the main activity that they spent time into. Sorry, I couldn't find much time to get it into a proper nice architecture diagram, but then this is what the old system looks like in terms of the TMS system, which would have an urban traffic control system within it, and would try to and the SIP subsystems, basically the detection devices where you have in-ground detectors and infrared camera detectors and pedestrian call buttons, and then the traffic signal infrastructures. And then you've got the other supporting infrastructures and stuff as such. I know it's a pretty bad thing. I try to maximize in terms, if you want to have a view, how do they look? There's the controllers and the mass down poles and stuff, signal heads and the loop detection systems, and a pretty cool push button. So, what does a traffic management system actually do? So the urban traffic control system is just a part of it. So it can have further enhancements in terms of including incident management or driver information systems, ramp metering, and everything together. So each would be a particular module, like how we have it in doors or stuff. Like we have one particular package. So something like that. This would be another license if you needed one. And then that could be integrated together so that it makes the operator's job easy. They don't have to sit on individual systems and monitor each of them separately. Rather than that would be an integrated system in just one screen, basically. In terms of the hierarchy, if you see the workstation, the TMS system would looking somewhere like that. And then one level down would be the adaptive control system, and then one level down would be the local traffic signal controls. So in terms, if the design was pretty robust in terms where you can see we've got two servers, one in the main island control center and one on the alternator island as a backup, as a shadow, in case if it's like a disaster recovery thing. And then you've got one level down is the urban traffic control system, and one level down is the traffic signal controllers, and they are all integrated into. And then there were specifications of having this many workstations with many monitors and stuff. In terms, when we go next is where we started doing all the analysis stuff. So first step was like modeling. So there was an entire citywide traffic model which was developed in terms to identify patterns, and then try to coordinate the arterial routes, and detail all level models were developed, and then each would have this kind of a staging arranged in a way. So you could see that basically where we just operate split phasing over there most of the time, where you're just going green in one approach. And yeah, and you could see all those. It's really wide. So unlike in New Zealand where we can just cross throughout in one go, but then in Abu Dhabi, the lanes are like literally 8 lanes in one side. So you just cross half until the median, and then you wait for the green for the next one. In going into design, it was really a robust process. We had first a sketch analysis to identify, okay, how are we going to divide the entire 125 intersections into particular regions where you could target based on their operation. You want, and in adaptive control, we call it regions only because like one region particularly operates well if it's like having less than 10 intersections, and then it's all in one corridor and they operate a same cycle time. So if you actually go on the travel speed, basically you're going to hit green all throughout. And so that was one of the first thing. And then the next step was going to the site, trying to look into where can be, where are the issues, what other considerations that you have to give based on the location of the intersection, if it's close to a hospital, if it's close to presidential palace, or if it's close to a mall and other places, and what are the actions that we could do. A kind of a high level FMICA was done in terms of trying to identify what would be the requirements. And so kind of first, the backup server idea came up through this process. So having, because there was a suspicion that the main island traffic control center can get flooded. So then what would we do in terms of operations? And then the three levels. So if there is a communication loss between the traffic management system and the UTC system, then the UTC takes over. And then if there is communication issues between the local controller and the UTC system, then the local controller can take over and it can still operate on its own. So that redundancy was there. And basically physical and other FMICA wasn't done based on that. They had a robust maintenance process and enough spares for all the equipments over there. So in any case, they take traffic signals very seriously. So if there's any faults today, it would be really rectified within this week, or in terms of a small fault, or if it's a really emergency, there are road safety patrols who actually go there and operate, control the traffic and get it done. So that was more of that process. And then the most time was spent on planning, scheduling, and interfacing with other parties. Like since we were only doing the traffic controller replacement, whereas another party was doing the CCTV replacement at the same time, and another party was getting the fiber optic cabinets ready, as well as we had the power connection for those controllers as well. So there were a lot of things which went on together. Like there was a loop cutting team which went out for cutting 4,000 plus loops, and then traffic engineering, which was me and my senior. We were doing all the configurations which were needed for the controllers, and then next was testing and getting it ready in terms. So everything had a process, but then nothing was recorded as such, everything was paper based, or, I mean, now when I'm thinking from an SE perspective, not a designer perspective, then I really feel like it would have really been an advantage if things were adopted. Kind of the key interfaces that we look at would be all the internal interfaces within the same Department of Transport, the neighboring islands and CCTV installers and internal DOT departments. Whereas the external interfaces, there were a couple many. I've just listed a couple of them which I could remember based on the meetings that I've had. And so in terms of public transport, buses or police or civil defense, hospitals and exhibition centers and heritage places. Then comes like the time where we had to go into the build mode, basically when the loop cutting team's done with their loop installations and it's got checked, and then CCTV installers and the fiber optic homes installers have got their own schedule. So, and we decide, I mean, overall, this was the summary of the thing where you've had 4,000 plus detectors to be done, 2 per intersection CCTV, and then all these other systems. The main key challenge over there was all these were live intersections. They were brownfield, they were active. So we had no permission to keep it shut for the entire day to do it. So the replacement time was constrained, 10 p.m. from midnight until morning 6 a.m. It was like literally 8 hours and sometimes even less, basically, when it comes to really downtown, because over there we had only like say 12 to 6, so kind of that. And we could do one controller replacement. The main thing was trying to get it scheduled on time and finished on time. It was a bit difficult and not an easy challenge. So we had a lot of planning before, like you had the field team ready who are like who have knowledge on the controllers, connections, the local, since you're going to use the existing cables for most of the network. And yeah, just lifting out the old controller and putting the new one and connecting doesn't work. So you had to get everything sorted based on whether there's comms, whether there's uh, if, and then so to support that in that space, there was FAT, which is done in the control environment back in the UK. And then all the QA process that we did in terms of traffic signals configurations were like all consultant review, client review, simulator testing, and then we get it tested in the actual test site was developed. You can see on the right-hand side where there's a test board, but that's only for a 16-phase controller where you've got only 16 groups. But bigger intersections couldn't be tested in that space. And so we upload that into a test controller, try to see whether it's communicating with a system back in the control room. Is it working? And then just get the motherboard ready. And then once the commissioning's done on site, it was kind of like the next process. Once everything's done, you go over to this. I mean, when you're handing over, there's a consultant rep, there's a client rep there, and there's handover checklist. You go through entire thing. So you need that kind of at least half an hour to 1 hour to get that done. So the technicians really need to speed up in terms of getting that replacement done. Things do what do you say? Mistakes do happen. So there were a couple things to learn from those things as well. And then once a corridor is ready, then the traffic engineers like we have to go to site to get some extra data and stuff, how much queue to estimate the queues and stuff, and then go back into the UTC system and try to develop an adaptive control plans and stuff, how it works. And then the next level would be the software engineers come and then program the TMS so that it looks very nice and elegant. So for an operator, it just looks like this. So if it's green, basically it's okay. They don't need to bother. If it's red, it's just red. It's a problem for them. Pink, it's another kind of a lamp failure. Blue means communications failure, and orange means just a warning because there's some detector issues or something. So there were typical color codes for all those, and then you could actually customize this dashboard based on your own thing, like your role is like if you're an operator, you would want to know whether all these things are working fine. So you would, on the bottom, you can just really click in easy dashboards that would give you status of each system, subsystem throughout. Then this was completely tested based on all the validation plan that they had. Like, okay, does this feature work? Like right click and can they operate a plan? Right click and then can they do this thing and all like that? And complete end to end. Then there were some problems with the backup server testings, but then that also worked once it was fixed. But it was like the main server switched off. When does the backup server come up? And then green waves, basically, where you want to what do you say, give priority to the presidential palace was here, and if they want to ever go to this side of there's another palace over here, So kind of they would want a green wave throughout. So like just to create those plans and stuff, admin controls, or whether those things work. So it was kind of, I think, almost a month of testing and then reconfiguring and testing again and stuff throughout. And throughout this process, where we were receiving train as traffic engineers, we received training from Siemens, and then operators and maintainers, they received training from us. There were refresher trainings for them every 6 months, and then kind of like trainings on how or their everyday tasks and how to customize stuff for them as per their role. And then we were on call. So I actually had a dongle with me, so I could just connect it to my laptop and I could remotely access the system and control the system from my laptop. And then couple of support, like every day morning we had to be there for support, try to train them for the whole 1 year. We were doing that as part of our role, so to build up that capability with the operators and maintainers. And every time a challenge used to come, and then you identify issues, and then there's always a process that you follow, like trying to find the root cause and stuff. And then keep that in mind, that so that you become an expert, like a doctor, basically. And then a couple of special event supports when they had events, like right now they're having basketball over there. So that's kind of the project in terms of how I've been there. I was wearing a designer hat, so I would have I would have been rather tutoring in this presentation rather than actually speaking in terms of SE. But then this is like where I've tried to do a thinking of like how things were there, but then they were not formally as systems. So on the left, that's the image of the kind of a stethoscope for this traffic signal controller that I miss, but that's okay. A couple of lessons learned. Really, SE could have really done in a proper way. It could have really reduced all that lot of paperwork and change management in terms of they're adding new scope, adding new controllers, adding new things, asking for new integration facilities with third-party controllers and stuff. So there were a lot of back and forths with that, but that could have been managed much better. Planning was really the key thing in this whole process, I would say. And there were a lot of signatures, approvals. That's fine. And I think a kind of a what if analysis for expected failures would have been good. Was not done much because I mean, say a couple of times we couldn't get the controller to communicate with the system, and then possibly we had to rush back, get an 5G modem or 4G modem, and try to fix it up for the temporaries. And then site knowledge is really good in these kind of cases where there's uh, historic cables and other things, utilities over there. So yeah, and trying to choose a test site which is like isolated from the city for the first time when you're implementing, and then trying to put processes in, like say those improvement processes that could really help with feedbacks and stuff. And the whole thing was like, if you don't act, all this is SE, but then they won't really accept it as an independent SE would have done it. But yeah, if we don't do it, there are its own consequences. So like simple processes, if they're not followed, they're really, especially with traffic signals and high speed intersections like over there. One of the couple of mistakes that I've done in my life is just forgot to tick one box. And then if you don't forget one process, it goes from from green to red rather than going from green. They have flashing green, amber, and red. So a person got, luckily the controller is proofed enough so that it doesn't allow the other approach within the intergreen period. So that was good, but then the person got a traffic violation fine because of me. But there can be other serious consequences in terms if you don't follow certain processes, and it would be really a waste. I mean, you won't get that quality delivered within this particular time limit. Yeah, that's it from me. Jess, back to you.
Thanks, Dhanush. I think we'll open it up for questions. We're a small enough group. We don't need to be too formal here. Thank you. Thank you very, very, very much for presenting on this. I know that um, we've been talking about an ITS presentation here to this community for quite some time. And so I'm glad we finally got it across the line. With respect to your architecture diagram, don't feel bad. We've all seen worse. Um, um, I also, one of my major takeaways from this is that when I've been driving through a city and I feel like I just keep hitting every red light, now I know that that's actually a red wave that's inhibiting my progress.
Uh,
And I know that I'm personally
so
being
yeah,
persecuted, but no.
if you're
I
talking about New Zealand, New Zealand has a different strategy. So
mm,
they follow the GPS, so they keep the pedestrians on top. So if you actually want a couple of corridors in New Zealand are like, say, Queen Street back in Auckland. If you go walk, basically it's like walking coordinated. If you go on a proper walking speed,
yeah,
it's more coordinated by walking rather than actual cars.
that's
So
fabulous.
they want to discourage things over here. And the CAT system over here, it's pretty difficult. So if you see one intersection, if it's operating, say, 80 seconds of a cycle time, the next intersection is operating 100, they're not going to coordinate to each other anyway.
Mm.
They're going to be either, so we've had these conversations with ATOC a lot of time, and then it's basically downtowns like that just to discourage people from driving. That's a simple answer. But
Nice.
but in Abu Dhabi, really, it was well coordinated. Otherwise, we would really get calls from all the high-end leaders over there. So
Uh, Rick asked a question in the chat. Apart from the scale, what else is different in New Zealand from an ITS perspective?
in terms of scale, the challenges that you have here is you've got so in Abu Dhabi, it's like kind of planned city. So they
Mm,
built roads before and traffic signals are there before any other development is there. Whereas in New Zealand, you're constrained by the road widths and everything and those things. So the implementation wise, it's difficult. And SCATS has its own kind of strategies. What do you say? Efficiency issues. But since it's been historically used here, nobody wants to go and replace things with another new technology. That's $1 billion cost to it.
So I was very lucky
Yeah.
to have been in Abu Dhabi in 2017 for the World Skills Competition. And I was amazed, although I guess I shouldn't have been, at just how well organized the whole layout was in that main central island of Abu Dhabi. It was pretty impressive.
It was completely rectangular system. So they've got, yeah, that's how they've done it. So, and there are very few intersections in Abu Dhabi which would be unsignalized. They would never do that because of the number of lanes that you have to cross. And, over here, you've got a lot of priority control ones. You just give way or stop control ones. But back there, no chance of those. Mostly roundabouts. Even some roundabouts are actually signalized.
Luke's got a
Hi,
question.
Luke.
Hi, so less of a SE question, more of a curious question. So there's a lot of talk about AI and use of AI. Is that something that your industry's discussing? And if so, what do you think are the main challenges of implementing such technology with traffic management?
AI, I've not been through that process as much, but can be used in terms already. You've got this compute. I mean, all these adaptive controls are computerized. I mean, they're all based on intelligence and stuff. But I don't know whether traffic signals would be in terms of AI. Rather, the CCTV or the intrusion detections, those systems can be more taken into AI rather, like how if you have to if you have to identify whether a pedestrian's actually there standing near the signal and try to get that image and stuff, and with AI could help in that space. But I don't see whether AI can be in this traffic signal space because it's more safety and other considerations. Might be there. I might be wrong though. Sorry, look.
Cool, no worries.
Tom.
So, Dhanush, thanks. That's an
Hi,
awesome
Tom.
talk. You talked about how the rollout of the controllers was gradual. Was there like effort to, I guess, do some design or at least risk assessment or safety assessment for the hybrid system where you have a mix of new and old hardware, or do you have special modes in the new hardware for when it's in the hybrid, not fully rolled out?
Yes. So what we did initially was this. There was Scoot is a simple system. You can actually operate 64,000 intersections from just your laptop. Yeah. So it doesn't require that big server. So for them, that big server rack was basically as a future-proofing thing. Like they have that architecture plan in their mind that, okay, today we're going to implement this state-of-the-art, this thing. Tomorrow we're going to integrate. So now they've actually upgraded the system already. Now they're using as a modeling system, modeling tool, live modeling from the road. So there's live data that is coming, feeding into a model. That model comes, runs, and gives the data back, and that sends back it to the controller. So they've done that upgrade already. So they wanted to have these kind of features within and to expand. That's why intermediate, we just had a normal Dell server, a small server, where we were just operating the other controllers the same way. So like you said, in that mode, we had so none of them were at working adaptive control. They were all working the same plan. So the other controllers had a time of day plan. This one also had the same for that instance. Until the corridor is ready, until the whole thing's ready, we were waiting.
Cool.
So it talks to each other. There were complications where this controller ends, and there's a region where we're using C900 controllers. So they both don't talk to each other. But you can operate them from the TMS, that stuff. But they both really don't coordinate and talk to each other. So yeah. Hi, Rick, you have another question?
You're muted. You're still there.
Sorry, yes, I'd also hidden the Zoom screen behind another couple of screens I was working on. So yeah, the question is noting the AI question that Luke asked before, but what else does the future of ITS hold for New Zealand?
Really, in terms of ITS, so we do have, I don't know, Russ is not joined. So I thought Russ Pinchin would have joined the call. So he's from Wakakotahi. So NZ has proper specifications and requirements already there. So possibly use AI to get that out, get the requirements out of it, try to build like how US has done. US has done a complete setup where you've got requirements for each ITS mapped into what can be the user needs and everything from all levels, from functional, physical, everything. So try to map that. That can be a good future because right now we're at that stage where you kind of have the same systems. So, if you have that architecture plan ready, like for the region, for the entire country as well, and that could be a pathway to a couple of us, and then possibly more jobs for us SEs, in that space. That's only a matter of thinking whether the government likes it and wants to spend things on it.
Money. I did pop a link in the chat to the NZTA Intelligent Transport Systems webpage. so that if you can, at your leisure, peruse the standards. And I do see Russ Pinchin's name on a couple of them along the way. And some others, frankly. I think that it's good to know that in the intelligent transport systems space, there is an approach for standardizing, for developing general sets of requirements for the elements of the system, as well as some general requirements for the system at large, and for security and safety and commissioning and all that sort of stuff along the way, because making a mistake in this sort of implementation could have a real negative consequences if somebody makes an error. Probably maybe time for one more question if anybody's got it. Just gonna keep an eye on whether anybody comes off of mute. And it looks like probably not this time. I suspect others may be equally hungry and ready to go. So I'm going to do one last screen share here, team, if you can confirm that it's back up on there.
Yes.
Awesome. So just to let everybody know, we've got 2 events that are coming up relatively quickly. The first, the chapter is, we're really excited to be hosting a roundtable in Auckland with Kwok Do, who's the director of INCOSE Sector 3. That will be on the afternoon of 10 August. INCOSE New Zealand members will get a calendar placeholder, and we'll have some details about that event. It's expected to be a relatively social exchange more than a formal technical interchange. So if you're in Auckland and you're interested in coming along to that, sweet. We'll be excited to see you. And then next, we will be planning our next meetup for August or September, sort of the end of August or the beginning of September 2024. We still need to confirm exactly who the speaker is. We've had a couple of volunteers, and we're quite happy. We're always happy. We're always open to presentation topics, case studies, lessons learned, roundtable discussions of stuff that you might be wrestling with and grappling with. We might not record some of those and post them on YouTube unless everybody's comfortable with that. But nevertheless, here is as a chapter, we're doing our best to make sure that we've got stuff that we put stuff on that's relevant to you and interesting to you, and help support you as systems engineering practitioners here in New Zealand. All the different ways to connect, all the different stuff that we've got in terms of reaching out. Thanks everybody for coming along this evening. Really appreciate your time and attention, and we'll leave it there.
Thank you.
Thank you very much.
Thanks very much.
Thank you.
Yeah.